Hi friends, this is Soft Freezing. You are welcome to this presentation. We are going to be looking at SAP2000 introductions, and we will be considering the modeling and design, analysis and design of a curved roof beam, steel beam. Okay, just like this. Okay, so this is SAP2000. Once you launch it, you have it just like this. You just have to click on this new, or you go to file right there in the drop down menu. You select a new model, and then you give it some time to create a new model successfully. All right, so new model is about to be created. You have a new model dialog. In this provision, you will have to select your unit at first. Unit, I'm going to be considering kilonewton meter. Okay, so and then the default material will be considering United States. All right, so you click on the grid only. So once you click on the grid only, you will have this. I will explain this better, so I'll just have to click on OK. We'll come back to explain this and set out the grids, because we are considering a frame, a simply supported frame in 2D format, and then we will be going to running analysis, 2D analysis, and as well as design. Okay, so click on OK right away. So once you click on OK, you will have this. It consists of two windows. You can see the 2D window, you can see the XY plane, and you can see the 3D window. So if you zoom closely, you may use this tools window. Zoom closely here so you can understand the coordinate system. See, the Z is pointing upward, and then you see the X and the Y. All right, so this is the coordinate system, how it's being arranged in SAP2000. Okay, so I may not necessarily be making use of the 3D window, so I have to close the 3D window right away. So this is the 2D window, and this 2D window you can also switch to 3D using these provisions to switch to 3D, and then you can switch to XY and as well as XZ plane. But we'll be looking at the XZ plane because we are dealing with a simply supported steel beams, and we are going to be modeling a curved steel roof beam. All right, so I want to go back to the 3D. All right, so you actually understand. So we want to set out the the frames. For us to set out the frame, you have to first of all set out your grids. So for you to do that, you can double click right there and to have a grid just like this. Okay, so in these provisions we may be using our explained display grids as coordinate and as well as spacing. All right, so see the system name is global. All right, so this is the X grid data, the Y grid data, and as well as the Z grid data. This has to do with the vertical offset. Okay, so we are considering only the X grid data and then the Z grid data. For the Y grid data, we are going to be having just 0. Okay, so for that we have to delete this, delete this, delete this. We're having 0. Okay, we will have grids in the Y direction. All right, so for us to set this, you know, if you have to use coordinate settings, you have to start from 0. There is always a 0 point. Okay, 0 point is the starting point of the grid lines. Okay, so I want to go to space now. You see a 0 point has changed to D. Originally 0 point was at A. Okay, so if I want to continue, I go to coordinates. Let's set it right away. From 0, I will be having you know, we are considering span of 36 meter. Okay, 36 meter span. So an intermediate grid as in 36 meter now, divide by 2, you will be having 18. All right, you'll be having 18 meter. So the intermediate is going to be 18 meter. All right, then since we are considering a coordinate, the next grid, which is C, is going to be 36, which is 18 times 2. All right, which is 36 meter. just like that. Then for the D, we wouldn't have D, so you have to delete off D. You have something of this kind. Okay, for the height of it, from 0 we will add height of 6 meter, and then for the arc, we are considering a curve beam, then the radius, okay, the radius is going to be 2.5. So 2.5 plus 6, you are having 8.5 meter, just like that. Then for the Z5 and 4, we are going to delete that, so we'll be left with this. Okay, so if I should activate spacing now, you will notice that you have 18. All right, and then you have at first you have Z1 6 and Z2 2.5. But if you activate coordinates, you will be having just like this. Okay, so you can set your grid data using either coordinates or spacing right away. The size of the bubble can be changed as well. You can see it's 1.25, so you can reduce it if it's too big. All right, so after which you just have to click on the OK button. So once you click on the OK button, this is what you will have. Just as I said earlier, we are considering frame structure, a steel beam. Okay, so you have something of this kind. So you can now go to the XZ plane, which is the vertical. Z is the vertical. So you're considering the vertical and as well as the horizontal XZ plane. The Y direction is 0. All right. So you click right there to navigate to XZ plane. So this is what you have. All right. So after which, the next thing you'll be setting is the material. You have to define material. Come to define. Click on material. In this material dialog, you have to remove this. At first, delete that. We don't need that. We will delete this. But at first, let's just define the material. Click on add new material. So in the add new material, you can see you have the region to be United States, and then it is steel. You will have it to be the material type is steel. Okay, the standard. We are going to be taking this STM 833. All right, the grade is also 33. Click on OK. So once you click on OK, select this and then remove that, because we may not necessarily need that. All right. Okay, so after which, click on the OK button. So that material has been set for our steel design. Okay, we will be dealing with stanchion as well as the beam. Okay, so go back to define again. It's the section design now. Okay, frame sections, select there. So in this provisions here, define the property is empty, so you need to add new, import new property. Okay, so you click on the import new property. So in this import new property dialog, we are dealing with steel right away. Frame sections property type steel. Okay, so you can see if you click on the drop down name, you have concrete. Okay, so you select the right property, which is the steel, and we are doing with I sections, this one. So click right there. This will take you to our directory where you have to select the I section based on the code that you want to use. All right, so you can use any of the code. There are a lot of codes here. Okay, but we'll be considering these codes. All right, so open that. All right, so in this code you have a lot of steel sections here. All right, okay, so what we will be considering steel section from 200 by 100 by 4.5 and by 7. We consider from there to the end. Why we are selecting all of this is because after design, the program will be able to select any of this for the design. Okay, any of these that will pass the design. So you have to highlight all of that and click on OK. So once you click on OK, you can see the section name, which is the highest section here, display on the color as well. So if you check here, you can see also if you want to modify any of the nodes, you can do that. Okay, see the material here, A33. Okay, so after which, click on OK. So once you click on OK, what you now need to do, you need to activate what we call auto selection. That auto selection will enable this program to design and select a suitable steel sections for this particular frame we are going to design. So for you to do that, you come to add a new property. Okay, in the add new property dialog, you can see this auto select list. Okay, this one, click right there. So this will show you, if you check originally, the auto section name is auto 1. you remove the one. Let me just make it only auto. The auto sections type, you can see it is steel. All right, so if you see starting section is median, okay, you can't take anyone, but we will choose the one that is going to start, which is the smallest section so far, is the one we're going to choose after design. All right, the program will be able to now choose the sections that will be suitable for such steel based on the load that is applied on that steel frame. Okay, so what we do now is you have to select this first one, highlight all of this, okay, and take it to these provisions. So if you check your starting section is media, so I want to be telling the program the sections is going to start with. All right, so after which you just click on override. So once you click on override, you select the sections. Any section you select now is the sections that is going to start with. It will appear here. Okay, so I want you to start with this first section, 200 by 100 by 4.5 by 7. All right, so click on OK. So once you click on OK, the starting section has changed, okay, to that. All right, so after which you just have to click on OK. So once you click on OK now, you scroll up and then you see the auto sections. You choose that and click on OK. All right, so after that has done, we are set to model the steel frame now. Okay, so you see by this side you can see the tools. We use these tools to do modeling. All right, so or you can also come to draw. If you come to draw, you see the same tools as well. Okay, so we use this draw frame. You can see that draw frame. We are going to use it to draw the frame. So click right there. Once you click right there, you can see the line object in the property of object dialog. See the line object is straight frame, okay, and then the sections is this, but we are going to select here in the drop down menu. You make sure you choose auto, right? So once you choose auto, every other thing leave it at default. Then we start to place the we start to draw the frame. We want to start from the steel stanchion. Okay, that is the steel stanchion we have drawn. You just have to right click to deselect the command to draw another steel stanchion here. Okay, just like this. Deselect the command. Now the next thing we are going to be drawing is the steel roof beam, the curved steel roof beam. All right, the curved steel roof beam. And what we need to line object type provisions, you select this one, curve frame. All right, you select curve frame. So after you select curve frame, you pick the first point and then you pick the last point. So once you pick this point, you see a dialog will come up. A dialog will come up just like this. So in this dialog, under curve type, you see it is circular arc, 3 points coordinates. Okay, 3 points. So we have selected 2 points, remaining 1 point. You can see the section properties is this one. So select in this drop down menu and then be able to select auto. All right, we are using auto. Okay, this one. All right, after which you can see the third point. You have here to be 0. So you have to take the intermediate half of 36 meter, because it is 36 meter. That is the length of the space between the two stanchions. So you are going to take half of it in that provisions. Okay, so in this provision now, what is the total height? The total height, we have the height of the stanchion to be the height of the stanchion is 6 meter. Then the radius of the arc is supposed to be 2.5. So 2.5 plus 6 meter, you will be having 8.5. So you have 8.5 right away. Okay, after which you just have to make sure that we are going to break the steel into equal parts. The reason is because we want to avoid error due to slenderness. So to avoid error due to slenderness, it is advisable to break the steels into equal parts. So you click on break into multiple equal length objects, select there, then come to this numbers of line segment, and then you type 36. Okay, type 36 in that provisions, click on OK. So once you click on OK, you can see this is the steel beams. All right, so you can just have to close this dialog and then deselect this command. All right, so you have something of this kind. Okay, so if you want to see it in 3D, you can come to these provisions and then select these provisions, then come to general options and then select sections. You can select extrude, select fill as well, and then you can apply that. So once you apply that, you can see this in 3D. Go to the 3D to have that. If you want to zoom closely, you can use that icon and then zoom it closely, then move this way. You can see this is the steel section. Okay, you go back to the XZ plane, go back to the XZ plane right there, then you can close this dialog first. Close the dialog first. We want to be adjusting this in order for this to have a proper model. Okay, so I want to use this window and take this provision closely, zoom it closely, then I will go to design, and then under frame I will come to insert point. This provision, click right there. So you will be having this. We want to adjust this edge to match together, so you need to select this first. I'm selecting only one, but we have to select all. So for us to do that, go to the XZ plane again, so you can see all the steel, just like this. Move this, then do a shade over it to select all the steel curve sections. All right, after you have that selected, you can now come to these provisions. You choose top center, that one. Okay, once you choose that, if you apply it, you see what happened. You see it has come down, okay, to fit in. All right, so the same thing is applicable to this. Let me zoom that closely so you actually see what I am trying to do. Okay, shift this dialog. I want to move this in a little bit. Okay, so I need to get this selected. I will zoom this just like this, and then get this selected. Get this one selected just like that. Okay, then this time around you'll be using bottom center. Okay, click on OK, then highlight this again, after which come to assign frame, and then set point. Bottom center too, you can see is adjusted. All right, so click on OK, and then exit plane again. Use this and zoom this closely, just like that. Then highlight this. After you get that highlighted, go to assign frame, and then insert point. This time around we'll be looking at the top center again, just like this. Click on apply. You see, so you have adjusted the steel to match together, just like this. Okay, so having done this, go to exit plane again. We have done with the modeling, okay, of the frame. So what we need to do is we need to now add support. So what you need to do is just have to highlight the steel extension, and then you come to assign again. So in this assign, we will come to joint, and then restraint. Okay, and you have to select that. So once you select that, you can see different restraint joint right away. This is fixed, and then this one is spin. You can see a ruler, so you will need this. Okay, you select that, and then you applied it. Okay, you can see it's been applied successfully. So after which, the next thing we'll be doing is to load this structure. To load this structure, you need to define your loads. All right, for you to define your loads, come to define right there, and then come to load pattern. Click right there in this load pattern provisions. In the load pattern provisions, you have a dead load there at first. Okay, so you have to change the name to DR Deadload. You can see the self weight is 1. You add a new one. You can see for this one, you can choose to delete that off. All right, click on yes, that is deleted. So the next load we are going to be considering is live load and L. The factor without have it to be 0, we define that later, so you need to just add that. The next load we will consider is the wind roof load, the wind roof load. Okay, so the factor also, sorry, the live load here, you just have to edit that, come to modify, and then make sure you change this to live load. Okay, this is what it's supposed to be. Then click on modify. See, it has changed to live load. Okay, so the next load is the wind load. So you go to W arrow. Okay, this is wind roof load, so click here and then change it to wind. Okay, so in this auto literal load pattern, select in the drop down menu and choose none. So we are going to define this. Okay, so this we are going to leave it as 0 for now. Click on add. Then the next load is the wind load in the x directions. Okay, so you just have to type that wind load in the x directions, and then you have the safe way to be 0 2, and then click on add. Okay, click on add. So we are having 4 different loads pattern we have set now. Okay, so click on OK. Go back to define again. Then load cases. Okay, in these load cases you have all of this just like this. These are the load cases. You have to delete this one. Okay, delete that one. So you can leave all of this is literal statics. That is load cases type. Okay, so after you must have get that done, you have to just click on OK. Click on OK right away, and then you go back to define again, and then load combinations. Click on the load combinations. In these load combinations, you can see you have no combinations here. There's no combinations, so you need to add for design combinations. So click right there. So it is a steel frame design we are considering. So this is steel frame design. So just click on OK. So the combinations is created. Okay, for the steel frame design. So you can edit that. If you select it and click on show modify / show combinations, you can see the combination 1.4. All right, for the Deadload. Okay, click on the OK button. So you can check the second one. Select the second one, check it. You can see the combinations. Okay, this is the default combinations. Okay, for the load pattern and the load cases that we have defined. So after we must have this done, you just have to click on OK. All right, so after you click on OK, we are to assign these loads now. So what we need to do is you come to this provision assign. Okay, and then you come to this frame load, and then come to distributed. Click right there. So in these provisions, you can see we have a load pattern DL, which is the dead load. So the dead load we have to do assign is we have to assign a dead load. So for used to assign successfully, you have to select the object you needed to assign the dead load to. So we want to assign it to the curved steel beam. Okay, steel roof beam, the curved steel roof beam. So we have to select all of that. So once you get that selected, okay, we just have to come to these provisions. The dead load we need to add here is 0.5 kilonewton per meter square. Per meter, right? Sorry, not square, per meter. Click on apply. So the dead load is applied successfully. All right, it's applied successfully, but you're not seeing it. To enable it, you have to come to these provisions. Click right there. All right, so click right there in these provisions. Go to general tab, then take this to standard. Click on applied. So you have their dead load just like that. Okay, click on OK. Click on OK right there, and then what you need to do again is you just have to zoom it closely to see the load you just applied. You will use this, sorry, and then move this. You can see 0.5 kilonewton per meter applied there. So go back to the XZ plane, right, to take this back just like that. So we want to continue to apply the loads. Okay, so what you just have to do now, click here, go to live load. Then before you assign the live load, you have to set previous setting. Click on this previous setting. All right, previous selection. Okay, then you can now change the load now to 2.5. Okay, which is the live load. Click on applied. So if you check here, it has changed as well. Okay, so the next load we are going to apply is the roof wheel load. Okay, so you select that, you click on this previous selections, click there. Okay, and make sure it is selected. It's now selected. This is the previous selections. So this is 3.6, 3.6. All right, click on applied. All right, we are supposed to select the directions of load. Is going supposed to be z directions. Okay, supposed to be z directions. So we are going to replace existing load with that, with this direction. So so what we have to do is we have to select the previous, go to the previous selections, select that. Okay, so we are replacing this with the existing load. Okay, so just click on applied. So you can see, all right, this is the wind roof load. All right, so the last load we are going to be applying is the wind load in the x directions. So you select that. Okay, so once they select that in the x directions, load directions, you need to select x right away, and then we will applying this same load to that. So we are going to select this, and then also select this stanchion. So we selected the two stanchions. So we have to add a prefix this with minus to show the directions of the applied load. So you click on applied. So once you click on apply, these are the loads applied. So we have successfully applied loads on this simple frame. Click on OK. All right, so once you have now OK, the next thing we have to do, the structure is set for analysis. The structure is set for analysis. Okay, so for the analysis, you go to the analysis tab, click right there. Okay, so in this analysis, you have to set analysis options. So we are considering XZ plane analysis. So you select this one. Okay, this is the right analysis you have to select for this structure. Click on OK. So after set that, you just have to let me zoom this closely. Select this. I want to just zoom it just like this. Okay, so click on analysis right there. So once you click on analysis, you just have to click on run analysis. Click on run analysis. The program asking us to save this project, so we'll save it as a frame, design. Okay, one. All right, so click on save. Click on no. Sorry, save yes, and then you can locate a folder, maybe inside a document, just like that. Click on save. Save it right there. Okay, so after saving it, give the program some seconds to analyze this structure. Okay, the analysis is in progress. All right, so the analysis is completed now. For you to view your analysis informations like the bending moment, the shear force, okay, you can just take that, click on applied. All right, so you just have to see the load cases and combination name Deadload. There's no load here, so you use this one. You have a load there, so you have to just apply that. So if I apply that, you can see the bend moment of the structure. All right, if you want to see the axial forces on the structure, you can see that there's axial forces on the structure. Okay, you can also fill it as diagram just like that. Okay, so depending, you want to check the wind in the x directions, you have to just apply to see the wind in the x directions. Also, you can apply that. Okay, so you can see that is the shape of the structure. You can also go to this and click on apply it. You have that. Okay, click on OK. The deform shape of the structure, if you click that, click on apply it. Okay, this is the deform shape of the structure. So this structure has been analyzed successfully. Okay, so for the design of this structure, what you just need to do, come to these provisions, click in this drop down, so let's start design. Okay, so once you start design, see the process is in progress. The program is designing the structure. All right, so you can see design is successful. Okay, some of the beams are failing. This sign showing these are the utilization ratio. Okay, from this 0 to 0 0.5, 0 0.7 is actually a pass utilization ratio. Then from this yellow, okay, through this red is warning, but this particular red, which is the utilization one, is actually failure sign. Okay, or failure symbols. All right, so this is the key that you use to interpret your design. So if you zoom closely, click on these provisions and check where you're having green. You notice this is 500 by 200 by 9 by 14 actually passed the design. This also passed, but it's showing a kind of warning. But this one failed. Okay, it's failed here. Actually failed here, failed also here. Okay, so let's look at the extension as well. Okay, this extension is using what? It's using 500 and it's having some warning as well. So all of these you can as well edit it to make them pass. Okay, you can as well edit it to make them pass. But if you want to edit it, you just have to highlight. Before then, you have to nullify the analysis. Click on OK to nullify the analysis. Then select all of this. Once you select all of that, you come to assign and then come to frame, see frame sections. So in this frame section, I think 500 by 300 will pass it. You can use 600 by 300. Let's see how it works. Apply that to the frame. So the frame is containing all of this for now. Okay, so what you just need to do is to run analysis again. Click there and then run analysis again on this structure. So once analysis is done, you just have to do your design again. Click here and then design the structure. So you can see almost all has passed. Okay, so this is how you edit your steel material depending on what actually passed and what actually failed. This one has passed. The one that is showing yellow color has actually passed, but it's showing warning. Okay, so we will be able to model, analyze, apply load, analyze, and as well design this difference successfully. We bring the lesson to a stop here to be continued in more advanced lesson using this program. So do it to subscribe, hit on the red subscribe button, and stay tuned for more advanced lessons.